Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to take a look at the ControllableGameEntity class. So let's go to our Solution Explorer. So right-click the Game Object folder and go to Add Class. We're going to call this ControllableGameEntity. So ControllableGameEntity. It's going to be a public abstract class. So when you can control an entity, that means it can be moved. So it's going to be a derivative of movable entity. Alright, what we did last video is we created an IControllable interface. So we're going to use our IControllable. Okay. So let's add our property here, which is going to be public input map, and that's from IControllable. Get private set. So that is from IControllable. Let's add a private field. So at the top of the class, let's add private read only input system underscore input system. Alright, between the private field and the public property, let's add the constructor. This is an abstract class, so we can make this a protected constructor. Controllable game entity. The parameters are input system. We need a way to have a reference to the input system. The color for our entity. Remember, this is a derivative of movable entity, which is a derivative of game entity, so we need to have color. So we need to add using Microsoft.xna.framework and using PGL2D.input. So color vector 2 position, float angle, float speed, string texture name, and then we're going to call base. And then we're going to provide the color, position, angle, speed, texture name. Alright, what we want to do here is we need to create the reference to our input system. So underscore input system is equal to input system. Okay. A controllable game entity. This is a derivative of movable entity. So we have a update entity method that we could override. Now I'm going to seal this. And I'm going to provide the pre and post pattern to our method. So let's override the update entity and let's seal that. Protected. Override update entity and let's seal that. Sealed. So protected, sealed, override, void, update entity. And we call base.updateEntity. The pre and post pattern means that it's using the template pattern. Before we do an action, we might possibly want to do something before that. So that is the pre portion of that. Then we do our action, and then we call post, and then we perform whatever we want to do after the action. In this case, we are moving our object. So before movement, we might want to do something to our object, process our movement, then after our movement, we want to do something else, possibly. So pre-movement, game time, process input, game time, post movement, game time. So those haven't been created, so let's go ahead and create those. Private void process input game time. So this is going to call that handle input that's from IControllable, but we need to prepare for that. Input map dot update. We need to update our input map by using the input system. That's why we needed a reference to our input system. For our inputs, if you remember last video when we created IControllable, the first parameter is a list of available keybinds, not all keybinds, available keybinds. So we need to get that, and we get that by using the input map dot keybinds dot where. We're going to use a link and we're going to use where. Predicate k dot inputs dot count, and we're going to have another predicate here. So we're going to count the inputs based on a certain mode, and where if that is greater than 0, that we are going to use that k. We're going to use that input map keybind. So we're going to count based on this predicate I. I.mode does not equal to released, and I.mode does not equal to input mode.none. So what this is going to do is it's going to count all of our inputs that if they're pressed or held. If that is greater than 0, we will use that keybind. Remember, keybind has a name, an action, and a list of inputs. So if that keybind, let's say attack, if any one of those input modes are either pressed or held, in this case we're doing the opposite, we're checking to see if it's not released and it's not none, which means it's either pressed or held. If that is greater than 0, that keybind is actually available for us to use. Let me explain this a different way. We have a keybind and we call that attack. We can attack by having space or enter, or let's say the number 1 key. Input map keybinds where k.inputs.count. Let's say I'm holding down the space bar, which means enter and 1 is released or none. But that action is still valid because the count, that will be 1. We're only holding down one of the 3 buttons, so that will become 1. So the attack action is valid, so that is why we check to see the count, if the count is greater than 0. So this is more complex than what we've been working on, where we have one predicate and then another predicate internal to that. So we are getting the list of available keybinds based on the fact that if any of the inputs from that current keybind is either pressed or held, then that keybind is available for us to use. And we're going to call it .toList. Okay. Once that's done, we're going to call handle input, and we're going to provide inputs and game time. All right, so let's go ahead and make that method public. Abstract void handle input list keybind available keybinds game time. So that is from IControllable, and we're making that abstract. Because a controllable game entity, it has to be handled appropriately, so we make that abstract. Now let's add our pre and post movement methods. These are going to be empty. Not everything will need to process information before or after we moved. So protected virtual void pre-movement game time. Base implementation will be doing nothing. Protected virtual void post movement game time. Base implementation will be do nothing. The last thing we want to do for this file is to actually set the input map to be a new object. Alright, so that is it for this class. Next video we'll take a look at base game. So I hope to see you next time.